In this video, I'm going to talk about inversely proportional and what that means. So here is kind of like a demonstration of what it means by inversely proportional. If you look at this kind of question here, so this is a field. And a farmer's going to plant some kind of crop in that field. But however much crop he gets out, I mean, there's a number of factors, but we're just going to look at like planting and so on. But the number of crops he's going to get out is kind of connected to the distance between kind of like each crop, if you think about it. So, for example, here's a description. He could the orange ones are kind of like the plants. So you could plant them this far apart from each other, and you can fit more of them in. Or you could make the gap between them bigger, but you won't get as many crops planted in that field because the gap between them is fairly large. So this is an example of what it means by inverse proportion, because if you make the distance between each crop small, then the number of plants you get is more because you've packed more plants in that field. But if you make the distance between each plant large, then you won't be able to fit that many plants in your field, so you'll get less kind of plants in the field. So this is what it means by inverse proportion, that if one variable goes up, the other one goes down by a proportional amount, and if one variable goes down, the other one goes up by a proportional amount. So this is what it means by inversely proportional. This kind of like a seesaw effect, that one goes up, the other goes down, one goes down, the other one goes up. So, and this is kind of like a perfect demonstration of that, because you know the gap, you can sort of see it for yourself, that if you have these rows of plants, if you make the gap between them small, you can fit more in, but if you make the gap between them large, there's less plants that you can fit in. So this is kind of like how they're connected. But the annoying thing is, how do you kind of write the notation for this? So let's say P is the number of plants that you're going to plant, or kind of so, and D is the distance between them, and the distance could be meters. Now we've just established that these two variables are inversely proportional, that one is the inverse kind of proportion of the other. But how do you tell someone that in a mathematical way? So this is what we write. We write P is our kind of first variable, the number of plants, and we write the same symbol, unfortunately, but then we write 1 over the other one. So this is how you write when two variables are inversely connected. It's just that it's 1 over the other. Now this is really annoying because it's the same symbol. The only difference is that when it's inversely proportional, the one on the right will be 1 over something. But if you think about it logically, I'm just sort of making this up, but if I make D equal to 10, then 1 divided by 10 is 0.1. And you can see that the bigger the number on the bottom is, 1 divided by that is a very small number. But if I make D equal to something like 0.2, then 1 divided by 0.2 is going to be 5. So you can see if the smaller I make the number D, the larger the output is. So this is kind of like the idea behind inverse proportion, because the bigger the number you divide by, the smaller the outcome would be. The smaller the number you divide by, the larger the outcome would be. So this is kind of like the seesaw effect happening here. But this is how you write it. Now, again, very similar to kind of like direct proportion. When we had direct proportion, we said that P is something like that. Then we wrote P is equal to something times D. This is very similar. If we have P is inversely proportional to 1 over the D, then the formula will look like this. P is equal to something divided by d. So if I had P is directly proportional to 1 over d squared, the formula would be P is equal to something over d squared. Or if it was, let's rub this bit out, if it was something like P is inversely proportional to 1 over the square root of d, the formula would be P equals something divided by the square root of d. So remember, this is the description. This is what the formula would look like. But then you have to work out what k is. So description, formula, description, formula. But then you have to work out what k is. Now let's actually do that for this example here. So we've just established that P is inversely proportional to 1 over d. That means the formula is going to be P is equal to something divided by d. Now we need some data. So here's our data. So in this field, if the farmer plants the crop 5 meters apart, then they can fit 800 in. If it's 6 meters apart, it's 667. 7 meters apart is 5, and so on. So let's just use the first one. Okay, to work out what the proportional factor is, this k, because we need that to complete the formula. So the number of plants is 800, and that equals something we don't know, the proportional factor divided by the distance, which is 5. And we would do k equals 800 times 5. So k is equal to 4,000. No, sorry, no, it's 40,000, sorry, yeah. Is that right? No, what I'm doing. Sorry, what am I doing? I've added an extra 0. Sorry, let me do that again. Bit of a mind blank there. 4,000, sorry. So this is the formula now that connects both variables together. P is equal to 4,000 divided by d. That's the complete formula. Now, just to show you that this formula works, is let's kind of use kind of like this one here. Let's use that one there. Okay, it may be a bit of a rounding error, but if we put 700 for the distance in, so 4,000 divided by 7. 4,000 divided by 7 is 571.4, but we'll round it to 571 because we're talking about physical objects here. So 571, and you can see that the formula does work. So then you can make predictions. So the prediction, sorry, it wants you to find out how many crops you could fit if you plant them 25 meters apart. So P would equal 4,000 divided by 25. 4,000 divided by 25 is 160. So you'll get 160 crops in that field. So that's inversely proportional. One variable goes up, the other variable goes down. In the next video, I go through some examples on this. And then the last video, we'll talk about the graphs of these. Okay, thank you for watching.